Let me ask you something. Who is an American? Supposing if I were to define an American as anyone who was born in the 50 states, including New Jersey. Well, let's look at that definition. Who would I be leaving out? I'd be leaving out folks who live in Puerto Rico, folks who live in the U.S. Virgin Islands, folks who live in Guam. I'd be leaving out people who became naturalized citizens. I'd be leaving out people whose parents were American when they were born, but they were born overseas. Well, let's take a look at those numbers. The population of the United States is about 309 million. The population of Puerto Rico is 4 million, Guam is 200,000, Virgin Islands is 100,000. So Puerto Rico, Guam, Virgin Islands makes up about 1.4% of the population. As of 2009, about 12.5% of our population are naturalized citizens. Can't imagine there are that many people whose parents were American when they were born, but they were born overseas. So that amounts to about 13.9% of the people that we were leaving out. So, in one sense, we say person's American who was born in America, we're about 86% accurate. But we're leaving out a lot of folks. We're leaving out a real richness of experience. All those folks who live in Puerto Rico, all those folks who made America our home. So, in much the same way, we started with trigonometric definitions that said, well, we're going to define everything in terms of a right triangle. The sine will be the opposite over the hypotenuse, the cosine adjacent over the hypotenuse, the tangent the opposite over the adjacent. But what we're going to do in this video is to expand our definition of what sines and cosines and tangents can be well beyond the right triangle. And as you'll see, there'll be a sort of richness there which you won't be able to appreciate yet, but sort of a richness of description that physics can employ. What you see before you is the unit circle, and that will be the basis of our new understanding of sines, cosines, of tangents. The unit circle is a basic circle. The unit part means that its radius is 1. Now, let's take a look at an angle like a 30-degree angle over here. And let's just take a look at where it meets the unit circle. If we were to drop a line down or drop a line up this way and this way, you would see that we have formed now a right triangle. So let's take a look at the definition now of sine, cosine, and tangent. The hypotenuse here is 1, and the sine is going to be the opposite over the hypotenuse, so it's the opposite over the hypotenuse, which is really the opposite over 1, which is the opposite. And this opposite side, really, if we have an xy coordinate system, is really just your y value. So that's your y coordinate. Similarly, if we take a look at the cosine, that's going to be the adjacent over the hypotenuse. So this side over that side. But the hypotenuse is 1, so you get the adjacent over 1, which is equal to the adjacent. And again, if we have an xy coordinate system, this distance from here to here is really just your x value. Similarly, the tangent is going to be the opposite over the adjacent. So it's really just your y value over your x value. Thinking about sines and cosines in terms of the unit circle can give us a really intuitive feeling. Let's, for instance, compare something like an angle of 30 degrees with an angle of 60 degrees. Now, what we just said was that in order to figure out the sine, really the sine is the opposite over the hypotenuse, the opposite over 1. So all you need is the y value of where the ray from the angle intersects the unit circle. Similarly, all you need is the x value of this point over here, and that gives you the cosine. So we've got a 30-degree angle here, and we have a 60-degree angle over here. Let's compare the sine of the 30 with the sine of the 60. For the 60-degree angle, if you take a look here, this has a much bigger y, and therefore it'll have a much bigger sine. However, its cosine, which is the x value, is smaller than for 60 degrees, 30 degrees. So just on a qualitative basis then, you can say that the sine of 60 degrees is going to be greater than the poor old sine of 30 degrees. And yet, the cosine, which is the x value of 60 degrees, is going to be a lot less than the cosine of 30 degrees. So I made a big deal at the very beginning of this presentation that our definitions of sine, cosine, and tangent were limited because they were always dealing with a right triangle. Thinking about the new definition of a sine, the y value on the unit circle, the cosine, the x value on the unit circle, let's take a look at some other angles. Supposing if we have a triangle which is not a right triangle, supposing if we have something like this, 120 degrees, which if you think about it as a triangle, 120 degrees is what's being swept out from the x-axis. Doesn't look like a right triangle at all. However, by our new definitions of sine and cosine, this angle, 120 degrees, still has a sine, still has a cosine. Okay, so let's take a look at the 120 degree angle. Again, our new definition of sines and cosines are simply the x and y value of where they meet the unit circle. So the sine of 120 here, you can see, is positive because it has a positive y value. But if you take a look at the x value is going to be negative. So the cosine of 120 is going to be negative because it's on the negative x-axis here, but the sine of 120 will be positive. In the next video, we'll be practicing looking at sines and cosines with the unit circle.